Kia ora, welcome back. I'm the TheKiwiCoder, and in this video I'm going to show you how to add damage to your AI characters. So the characters are using hitboxes for collision detection, which gives more accurate hit testing. When each character is hit, there's like this blink to white effect, which is achieved by modifying the color intensity. And each of the agents has also got like a health bar, just displaying like how much health it has left. And this health bar is drawn in screen space to prevent it from like shrinking and getting like too small if the character is far away from you. It also means that we don't need to align the health bar to the screen at all. And finally, when the character is basically, when their health drops to 0, they go into this cool ragdoll state, which you can then just play around with, which is quite fun. Sweet. So yeah, let's get into it. This video follows on from a previous video in the AI series, creating your first animated AI character. So in the scene here, I've just got a really simple AI character that is following the player, and you can see that the when I shooted it, basically the raycasts are just going directly through the AI character and hitting whatever's behind it. So the first thing to do is just adding some collision to the character, and that way we can start looking at taking damage and ragdolling the character. So the first thing, well, there's a couple of ways that we can do it. One is adding just like a rigid body and a collider directly to this object here, but that won't give very accurate sort of hit testing. Like it won't tell us if we've hit the head or the arms or anything like that, you know, if you wanted to do things like headshots. So instead we're going to use the ragdoll wizard, and you can open that up from this menu here. And yeah, basically you just need to fill out all of these fields. It's a bit tedious, but yeah, I use the hips for the pelvis and the upper leg R for the right hips, upper leg L for the left hips, and so on. So I'm just going to fill this out really quickly now. Okay, so that's all done, and just going to set the total mass to 100 just to make the character a little bit heavier. And when I push create, you can now see it's basically added colliders for each of the different limbs. It does recommend that your character is in T-pose, but it seems to work like good enough. You can then go and sort of fine-tune these colliders after the fact, but I'll probably do that offline. So yeah, if we just select like one of these bones, for example, we can see it's added a box collider, a rigid body, and a character joint. And there's a whole bunch of sort of twist limits and stuff that you can tweak, but I'm going to leave all of that stuff default just to begin with. Okay, so if we go into play mode, then it probably looks okay on the surface. Like I can walk on top of the character, which means it does have collision, and I think it managed to actually pick up that pistol. So let me grab this one. So yeah, now if I shoot it, you can actually see the sparks coming off the character, which is a good start. But there is like a slight issue, and it's much more noticeable if we go to the window analysis menu and open up the physics debugger. This basically lets you inspect the state of the physics world, which can actually be different from what Unity shows in the viewport. And you can see that if I just move the character back for a minute, or let me just actually disable, I'm just going to set the speed of the agent to 0, and yeah, I'll just unpause it now. So if I go to the scene view and select the physics debug tab, you can actually see those rigid body colliders. They're like flickering around quite a lot, and basically by default the ragdoll wizard sets up the rigid bodies in a simulated state. So we only want to be in that state when we actually ragdoll. When the character is walking around, this is kinematic flag needs to be set on every rigid body. So yeah, I'm just going to create a new script to do that now. So if we just open a new C# script, and I'll just call this like ragdoll, and just add this to the agent. Ragdoll. Cool, so open this up. Cool, so the first thing that we need to do is just get a reference to all of the rigid bodies that the ragdoll wizard created. So we can do that using get components in children, and just pass in the rigid body type there, and yeah, that will recurse through the entire hierarchy and get all of the rigid bodies. Next thing I'm going to do is create two functions, one called deactivate ragdoll and another one called you can probably tell, activate ragdoll. Sweet. So inside start, I'm just going to call deactivate ragdoll, and we already know in here that we basically want to loop through all of the rigid bodies in that rigid bodies list, and basically set the rigid body is kinematic flag equal to true, and then pretty much just do the opposite inside activate ragdoll. So here we want to set is kinematic to false, which basically means it's been simulated instead of controlled by animation. And there's one more thing that we need to do, which is get the animator, and when we activate the ragdoll, basically the animator needs to be disabled. So we can just get a reference to the animator inside start, and just here just call animator.enabled equals to false, and inside deactivate just call animator.enabled equals to true. Sweet, so that should be it, and that should basically fix the glitching issue. So if we pop back into Unity and go into play mode, so yeah, now if I go into the scene view and open up the physics debugger again, I'm not sure where that went, analysis, physics debugger, yeah, so now we can see that those ragdoll colliders, they're just sort of remaining static, and they're actually colored blue now rather than pink, which just shows that they are kinematic. Cool. So the next stage is just actually creating a health component for the agent. So if I create a new health component here and just attach it to the agent, then what we want to do is basically just create a new public float to represent the max health of the agent, and a private one, or I guess it could be public as well. Maybe I'll just make it public. And yeah, inside start, we just want to set the current health equal to the max health, and just create like a new function here called, I don't know, like take damage with some amount, and just check if the current health is, well, I guess first subtract the amount, and then check if the current health is less than or equal to 0, then just call some function called like die, and I'll just use Alt Enter to create that function. And in here, this is basically where we want to activate the ragdoll. So you need to get a reference to the ragdoll script here. So again, you can assign it in the inspector, but I kind of prefer just to get it using get component, which I guess has probably got a slight startup toll, but yeah, I don't know. It's less stuff to configure in the inspector. So yeah, inside die, I'm just going to call activate ragdoll. And yeah, I think that should be pretty much it for the health component at the moment. So now we just need to create another script to actually call take damage, and this needs to be invoked inside our raycast weapon script. So when a raycast actually hits something, currently the only thing that we're doing is applying a force to a rigid body, and in this case we have like multiple rigid bodies, so there's a rigid body per one of these joints, and we need some way to kind of point all of the rigid bodies back towards this single health component where we can call take damage. I'll just set the max health to 100, and I think one more thing, I'm just going to hide the current health in the inspector. Still nice having it public so I can access it from outside the script, but I don't want this value to be configured inside the inspector. So yeah, the way to do that is I'm going to create a new script called hitbox, and the hitbox script is going to be attached to every single one of these rigid bodies, and that hitbox script will point back towards the health script. So let me just create the new script called hitbox. So the hitbox script itself is going to need a reference to the health script, and I'm going to create a new function here called on raycast hit, and here it's going to take in the weapon on raycast hit weapon public void, and yeah, here we just need to call now take damage with the amount. So the amount of damage to take should probably be a property of the weapon, so I'll just create a new value here, damage, and I'll initialize it to something like 10. It's probably a decent default value. And here we can just call take damage weapon.damage. So now we just want to look for basically a hitbox script on inside our raycast weapon script when we actually collide with something. So I'm just going to copy this chunk of code here because it's pretty much the same, but instead of rigid body, this is going to be a hitbox. like this. And instead of calling add force, now we just want to call that on raycast hit and pass in this. So it's currently asking for a raycast weapon, and we're calling it from the raycast weapon script, so we can just pass this in there. Actually, there's one more thing I might pass in just for now, which is the direction of the ray, because we'll use that to do some physics stuff in a minute. So may as well just do that while we're here. Just add the direction to the take damage script as well, and then inside the raycast weapon script, we just want to pass in the ray.direction. Sweet. So the final thing is we've got these hitbox scripts, but they're not actually added to anything. So I could sort of go through each one of these manually and add it, but I'm kind of too lazy to do that. And so instead, I'm just going to do it inside the health script. So we already have a reference to the ragdoll component, which has got the rigid bodies. And if they are public, then I should be able to just access them. Although, yeah, maybe it's not super clear which of these start functions is going to get called first, either the health or the ragdoll. I know you can change that using the script execution order, but I don't really like relying on that. So I'm just going to do the same thing here. It's just going to be a one-off. We don't need to hang on to those rigid bodies. So I'm just going to call get components in children, rigid body, and just loop through each rigid body in rigid bodies. And now we just basically want to add a new component. So we just need to get the game object that rigid body is attached to and call add component. And yeah, create a new hitbox component for each rigid body. So that hitbox component has got a public field, which is the health, which we just need to assign to ourselves like this. And yeah, so now if I go into play mode inside Unity, when we hit play, we should actually see these hitbox components being added to, yeah, so now we've got a hitbox component added to each one of these colliders, which is quite handy, and it's pointing directly to the health component. So this actually might work. If I just get a gun and start shooting him. No, something's not working. It might be the prefab. That damage field might not have been set correctly. So if I just, yeah, damage is set to 0. So just need to set that to something like 10. And if I go get a weapon now and shoot him, yay! So now he ragdolls when he dies, which is awesome. Cool. So the next step is going to be adding like just some effects to the character. Okay, so the effect that we're going to go for is just like a blink to white effect. So I can kind of illustrate that. If you open up the skinned mesh renderer and then just double click the material, if you enable emission and then just bump up the emission value to white, you can then modify the intensity and make the character glow like this. And what we'll do is basically just every time the character gets hit, just set the intensity up and then just like blend it back down to its normal value. So let me just reset all of that stuff and disable the emission. And yeah, I'll just do all of this inside the health script for now. You could potentially separate this out, but it's fine to do it here as well. So gonna need a few public variables, one for the blink intensity, so this will be how bright the effect is, one for the blink duration, so basically how long it sort of fades out, how long it takes to fade out, and another one for the blink timer, and that will just keep track of where we are in our blend. So yeah, also need to get a reference to the skinned mesh renderer. So you can get a reference. It's not on the top level game object, it's actually on a child, so just need to call get component in children, skinned mesh renderer. Cool. And inside inside take damage, what we want to do is just set the blink timer equal to the blink duration. So each time we get hit, we just reset the timer basically. And inside update, just going to, first thing that we'll do is just decrease the blink timer by time.delta time. And yeah, the next thing is basically we just want to get a blending factor or a lerp factor, which is always 0 to 1. So we can just call mathf.clamp 0 to 1, which ensures it is between 0 and 1, and then take the current value of the timer and divide it by the entire duration of the effect. And now we can calculate a final intensity value equal to the lerp value times our blink intensity. And then finally we can just set the skin mesh renderer.material.color equal to color.white times the intensity. And yeah, basically if I was to put type like 1 here, that would just have like the color white, and it would just be the sort of default color that you see in the scene here. But yeah, if the value is more than 1, then you get that like bright sort of white effect. So yeah, I think that's pretty much it. So if we just go back into Unity and then set up the blink intensity value, I'll just pick like 10 and let's make the duration like 2 to start with. Now if I go into play mode, the character is black. Oh yeah, sorry, I forgot something. So yeah, it does work. Like if you shoot it, then it goes like bright white, but then it fades all the way out to black. And that's basically because this lerp value gets down to 0, and then when we multiply white by 0 we get black. And so the way to fix that is just add on 1 here, and that means the minimum value will always be 1. So if I go back to Unity, hopefully Unity just updates. Cool. Yes, that looks pretty good. So my animation has stopped, so I might just restart this. And if we just try out like different values, so if I set like quite a small value here, like maybe 0.1, yeah, then you get that quite cool sort of blinking effect. Blink intensity, I mean, you could bump this up something massive. It looks a little bit over the top, I think. Even if I set it to 1, you can see it even more. It's pretty cool though. Like it's seems to be quite a decent effect for not much code at all. Cool. So yeah, I'm pretty happy with that. I think I'll just try the rifle because this one shoots a lot faster. Yeah, it's maybe a little bit fast. Sorry, a little bit slow. I kind of want it blinking. Yeah, that looks way cooler actually. Okay, sweet. Okay, so it's the last step of the tutorial where we'll just add like a UI health bar to the agent here. So what I'm going to do is create a canvas element, and I'm going to remove the graphic raycaster because we don't need to interact with it in any way. And I'm going to use screen space overlay for this, and the main reason for that is I don't want the UI element getting smaller if I get further away from the character. So I'm going to do everything in screen space. And I've added the canvas element to the child of the agent here. So what I'm going to do now is create a child object just to represent the UI health bar, and create 2 more children, one to represent the background of the health bar and another one to represent the foreground of the health bar. And both of these ones, I'm going to add an image component to them and use the built-in background image that comes with Unity. And I'll set the background to red and the foreground to green. Cool. So we can't actually see this object. So to see it, I'm just going to go to 2D view, double click on the canvas, and now we can see the object there. So if I resize this UI health bar, the background and foreground elements aren't updating with the size of the health bar. So I'm just going to select both of them, click this little icon here, then hold down Alt and click this bottom right hand icon, which just makes the background and foreground elements stretch to the size of the UI health bar, which is cool. So I'm going to use a width of 100 and a height of like say 10 or something. So you can check the game view how this is going to look. It's about that size. Maybe it's a little bit too big. I might go with 80. Yeah, cool, that will do. So the first thing to do is basically synchronize the position of this health bar with the agent. So I'm going to create a new script called UI health bar and just add that to the root object here. And this UI health bar is going to need a target transform to synchronize with. So just open up that script and create a new public property called transform, and this is just going to be the target transform. Don't think I'll need the start function, but I'm going to do all the synchronization inside late update. So that just ensures that the target transform of the agent has been updated with animations and everything first, and then we finally go and update the UI to match that position at the end of the frame. So because the target transform is in world space but the UI health bar is in screen space, we need to do a conversion here. So we can do that using transform.position equals camera.main.world to screen point, and then just pass in the target transform position there. Cool. So this target transform I will set to the agent's head, which does mean if it animates and stuff, like if the agent were to bend down, for example, then the health bar would follow. You may or may not want that, but yeah, that's really up to your game, I guess. So if I just find the head object here and assign that. Now if I go into play mode, we should be able to see that the health bar, yeah, cool. So it now synchronizes to the head position of the character. It's probably need to offset it a little bit. So if we just open up the health bar script and create a new offset value here, so offset, and we can just add that offset onto the target transform like this. Cool. So the offset value, probably it's best to tune in play mode. So if we just go into play mode and adjust the Y value here, yeah, 0.4 probably go with. Cool, 0.4. So now the next thing to do is to actually adjust the health bar size. We want to resize this element here. So we want to resize the foreground element by stretching it down. And I've seen a few ways, quite a lot of YouTube tutorials, they recommend switching to this filled mode and then switching to horizontal, and that gives you this like fill amount slider, which is quite convenient, but notice what it's done to the edge of the image. It's like stretched it out quite a lot, so I don't think that looks very good. So I'm going to carry on using the sliced mode, and we do lose the ability to have that like fill amount slider, but we just need to do that in code now. So what I need to do is get a reference to this this foreground image inside the health bar. So because it's an image, it's going to be inside the Unity engine.ui namespace, and just create a new property here called foreground image. I'm actually going to need the background one later as well, so I'll just do both at the same time. And yeah, need to create a new function here called like set health bar percentage, and this should just take a 0 to 1 percentage amount, and we'll invoke this from the health script in a minute every time we take damage. But first we just need to calculate the width for the foreground image. So that's going to be a proportion of the size of this top level object. So we can get that parent width by just going parent width equals get component rect transform. So that's where this script is on the top level object, and the rect transform has a property called rect, which you can then get the width from. So the final width of this foreground image should just be basically multiply the parent width by the percentage value there. And finally we can set the width of the actual foreground image by using foreground image.rectTransform.set size with current anchors, and in here you can just pass in the horizontal axis and pass in the final width it should be. So the next step is just adding a reference to this UI health bar inside the health and invoking this function. So if we switch over to the health script and just create a new property here called UI health bar, and this is going to be health bar. So you could either assign this in the inspector again, or I prefer to just do it in code most of the time. So just call get component in children UI health bar. And now each time we take damage, we can just call take damage dot set health bar percentage. And because this is a 0 to 1 amount, we just want to take the current health and divide it by the max health. And Also, finally, when we die, we probably just want to hide the health bar entirely, so it's not hanging over dead characters. Cool. So I think that is pretty much it for the scripting part. So if I just assign the background image and the foreground image to the health bar script here, then hit play, go into play mode. Now, if I shoot the character, cool. So you can see that this health bar is now resizing, except the pivot is not quite right. It's still centered around the center here. So we just need to select the foreground image, click this icon, hold down Shift, and make sure that little blue circle is there, and click this one in the middle left here. And that basically moves the pivot point over to the left hand side of the image here, which is the pivot point is basically where all images and UI elements will scale from. So now if I shoot it, cool, so now it's all scaling around the left hand side. So there is still one small bug, which I just killed him, so I couldn't really show you. But if I look in this direction, the position of this element is still off, and there's kind of the easiest thing to do is just hide these two images here when the health bar is behind the camera position. So if we just go back into that health bar script, we can calculate the direction the health bar, or the target transform that we're synchronizing to, calculate the direction it is to the camera. So if we just get the target.position minus the camera.main.transform.position, and we're going to use a dot product, so this vector needs to be normalized. And an easy way for testing if an object is behind another object is basically is behind. We can just take the dot product of the direction vector with the forward vector of the camera of the object that we want to test. So in this case it's the camera, so we can just take the dot product of the direction with the camera transform, and if it is less than or equal to 0, then we know the object is behind us. So if it is behind us, then we can just set both the foreground image dot enabled equals to the opposite of is behind, and same for the background image. Cool. I think that's pretty much it. So just test this out quickly. Go back to play mode. Grab a. Oh, I don't even need to grab a weapon. Yeah, so you can see that the health bar is visible here, but if I look in the other direction, oh, there is a slight glitch. Oh no, it's just because I was clipping with the player. Cool, yeah, so the image is no longer hanging around in front of us like it was before. Sweet, so yeah, I mean that's pretty much it for this. So there's one more thing that I completely forgot about. When we shoot the character, currently it's just like falls limply to the ground. So it'd be nice to actually apply some kind of force when the character dies, which is why we are already passing through the direction to the take damage function on the health component. So if on the ragdoll, if I just create a new function here called like apply force, and just give it the force to apply. Force. Now we could just apply the force to every single one of these rigid bodies, but another way that I found looks maybe sometimes better, I'm still not sure, is you can just call like animated get bone transform, and then just get the hip bone, and then get the rigid body component from that. And with that rigid body, now we can just call add force and just add that force. But the thing that I'm going to use force mode dot velocity change, which just means it doesn't take into account the mass of the character. So now from the health script, when we die, basically just pass this direction through here, and this is going to be a vector 3. And on the ragdoll, just call apply force and pass in the direction plus some scaling value, which I'll call like die force, I guess. And I'll just create a new property up here called float die force, something like that. And one more thing that I'm going to do is, rather than just passing in the direction, I'm going to just set the Y direction to 1. That means the character will kind of always fly off into the air, rather than say like dying directly into the ground. So yeah, if we just set the die force to something like 10, then I think that should be pretty much it. So if I grab a weapon and shoot him, hey, so he kind of like flies off into the air, which yeah, looks sort of cool, and you can still shoot him. Okay, cool. Yeah, so that is literally it for this tutorial. Thanks for watching. Really appreciate it. If you want to stay up to date with this AI series and my future videos, then please hit the subscribe button, the bell notification icon, and give it a like if you have enjoyed it. Thanks for watching, and we'll see you in the next video. Ka kite!